You're using an AI chatbot, it's giving you incredible answers, and then it just makes something up. It says something with total confidence, but it's completely, utterly wrong. Well, today we're going to pull back the curtain on exactly why that happens, and we'll look at the brilliant solution that's basically giving AI an external, always up-to-date brain. The first thing we have to get our heads around is that a large language model, or LLM, isn't thinking the way we do. At its core, it's a super sophisticated prediction machine. It's been trained on a gigantic chunk of the internet, and its one and only job is to ask itself, based on every sentence I've ever seen, what's the most statistically probable word that should come next? That's it. And when I say its training data is gigantic, the scale is just hard to even imagine. To put it in perspective, if you were to sit down and read all the text that a model like GPT-3 was trained on, reading 24/7 without stopping, it would take you over 2,600 years. Just think about that. All that human knowledge, all that text, is basically memorized and compressed inside the model's brain. But here's the catch. Relying only on that memorized internal knowledge creates two massive problems. The first is what we call hallucinations. That's when the model just makes stuff up that sounds really convincing, but is totally false. And the second big one is the knowledge cutoff. The model's world is frozen in time. It knows nothing about anything that has happened since its training ended. So how on earth do we fix that? Well, this is where a really clever architecture comes into play. It's called Retrieval-Augmented Generation, or just RAG for short. Probably the best way to think about this is like taking a test in school. A normal LLM is taking a closed book exam. It can only use what it's already memorized, nothing else. But an LLM with RAG, it gets to take an open book exam. It has an external cheat sheet, a whole library of up-to-date information that it can look at right before it answers your question. Okay, but for an AI to look up the right info on its cheat sheet, it first has to understand what our questions actually mean. And since computers don't understand words, only numbers, we have to translate our language into math. This gets us to the absolute core of modern AI, its secret language, vector embeddings. So what is a vector embedding? It's really just a way to turn a concept, like a word or a sentence, into a long list of numbers. That list of numbers is called a vector. You can think of this vector like a set of coordinates, pinpointing that concept's location in a giant, multidimensional map of meaning. And here is where the real magic happens. On this meaning map, concepts that are related, like Tokyo and Osaka, they're both big cities in Japan, right? Well, their vector coordinates are going to be really close to each other mathematically. But concepts that are totally unrelated, like Tokyo and pizza, will have coordinates that are super far apart. This is huge. It means the AI can now measure meaning just by measuring mathematical distance. All right, so we can turn any piece of text into a numerical coordinate. But now imagine doing that for millions or even billions of documents. We need a special kind of library to store all these coordinates and search through them at lightning speed. And that library, for an AI, is called a vector database. A vector database is basically a super-powered library built for one thing and one thing only. It stores all of these millions of vector embeddings, and it's optimized for a single crucial task. When you give it the vector for your question, it can find the other vectors in its library that are mathematically closest, the most similar documents, and it can do it almost instantly. So now we have all the pieces of the puzzle. We've got the LLM, the powerful language brain, we've got vector embeddings to turn our words into math, and we have the vector database to act as our super fast library. Let's put it all together and see how RAG actually works, step by step. It's actually a pretty elegant four-step process. First, when you ask a question, it instantly gets turned into a vector. Step 2. The system takes that vector and searches the vector database to find the documents that are the most similar in meaning. Step 3, it retrieves or pulls out the actual text from those documents. And then, and this is the most important part, it hands both your original question and that retrieved text to the LLM. It's basically saying, okay, LLM, answer this question, but you must use these facts I just gave you to do it. So what do we get from all this? The benefits are just huge. First, because the LLM is forced to use the facts we give it, those pesky hallucinations are drastically reduced. Second, the AI's knowledge is always up to date. You just add a new document to the database, and the AI knows about it instantly. No expensive retraining needed. Third, it's secure. A company can connect its own private internal data. And finally, it's transparent. You can actually see which documents the AI used to come up with its answer. This really sums it all up, doesn't it? RAG changes the AI from being just a brilliant memorizer into an actual reasoner that can work with real-time, verifiable information. It gives the LLM's incredible language skills a solid foundation of facts to stand on.